Alright, in this video we're going to continue and go back to straight line motion, where we talk about position, velocity, acceleration, okay, and their relationships. Of course, we've always talked about our position function is s of t, and we always said that v of t is the derivative of s of t, and that the acceleration is the derivative of velocity, making it the second derivative of position. And we also can work the other way at this point, because we could say if we have the acceleration function, then the velocity is the integral of a of t, okay, and the position function is the integral of velocity, making it the double integral of acceleration. And we're going to use that fact right now in order to answer a question. So let's go back to we've done this guard dog problem before. We're going to add something to it now. The guard dog protects a building, but has a tendency to wander. He starts his building at time t equals 0 and heads on a straight path away from the building. For 0 is less than or equal to t is less than or equal to 16. The dog's velocity is modeled by the piecewise linear function defined by the graph below. And we want you to write expressions for the dog's acceleration, velocity, and position on the interval 9 to 11. So that's this interval right here. We're trying to write velocity, okay, and acceleration and position functions. So if we're talking about, let's over here, position, velocity, and acceleration. Okay. Well, velocity is what they give us. That's the graph itself. That's the curve. So if we want to find the position, we know that it's the integral of the velocity. So that's going to be the area under the curve, the position is, because they have that relationship between position and velocity, that the position is the integral of the velocity. And then acceleration is the derivative of velocity, which means that the acceleration is going to equal the slope of the curve. Okay. Well, the slope of the curve we can figure out. We have 2 points. We have the 2 endpoints. So a of t is going to equal that slope, which is negative 10 minus 10 over 11 minus 9, which is negative 20 over 2, or negative 10. So our acceleration is just negative 10. That is our acceleration function. Now to determine our velocity function, we have to take the integral of negative 10, which of course is negative 10t plus c. Well, what's c? What value of c? We need a value of c to have, we can't just have plus c, that doesn't work. Well, if we look at 9 here, our velocity at 9 is 10. That is our thing. Now we have to alter this a little bit, make it negative 10, and we're going to have to change it because we're starting at 9 and not 0. We have to make that 10 minus 9. Okay? And then plus c, but we're going to change that plus c, and that's going to be plus 10 because that's where we started. So our velocity function, our acceleration, I'm going to write over here, our acceleration function it's negative 10. Our velocity function is, now I'm going to distribute this out and combine things a little bit. It'll be negative 10t plus 90 plus 10, so plus 100. There is our velocity function. Okay? Now, we also have to do our position function, which is going to be the integral from 9 to t, okay, of the velocity function, which is negative 10t plus 100 dt, of course. Now, should have put that in here as well, I guess, but okay. We're going to do that, and what we're going to get, negative 5t squared plus 100t evaluated from 9 to t plus c, and that turns out to be negative 5t squared plus 100t minus 495, and we need a plus c again. We need to know what that c is, that initial starting point. Well, if we want to know, we need to know where the guard dog was at time t equals 9. It's not as simple this time as just getting over and selecting 10. So what we're going to have to do is figure out the area here, which we've done before, except now we're going to figure out the area from 0 to 9, and that will tell us where the dog was when this time began. So this over here, area is 1/2 the height times base 1 plus base 2. In this case, it'd be 1/2 times 15 times base 1 is 2 plus base 2 is 7, and that turns out to be 67.5. So this area is 67.5. And then this area, it's a triangle, 1/2 base, which is 2, so that cancels out. So just the height is 10, so this area is 10. So from here to there, the total distance that the guard dog traveled was 77.5. That is our C. So we're going to take that out. We're going to add negative 5t squared plus 100t minus 495 plus 77.5. Okay? And that turns out to be negative 5t squared plus 100t and then minus maybe 421.5. 420, alright? That's not right. I subtracted wrong there. Okay. 417.5 makes much more sense. Minus 417.5. So our position function is just that, negative 5t squared plus 100t minus 417.5. Okay. And those are our three expressions. Alright, now we talk about displacement and distance. Displacement, that is going to be the difference between where we started and where we ended. Okay? So if I'm traveling along and I go 75 miles in this direction, and then I turn around and go 20 miles in this direction, well then, if I do that, then my displacement would then be 75 minus 20, which is 55. Now the distance, okay, the distance here would be the total amount we've traveled, which would be 75 plus 20, which of course is 95. So for displacement, we actually are taking the integral from A to B of the velocity function. The velocity. So it's the integral of the velocity. Whereas distance is the integral of the speed, which of course is the absolute value of the velocity. Okay. So let's look at how we would do this, and we'll do it with a calculator in hand. A particle moves along a straight line with a velocity v of t equals t squared minus 8t plus 12. Find the displacement on 2,6 and find the distance traveled on 2,6. I'm actually going to change that. I'm going to make it from 1 to 5. Okay? Because on 2,6 they're actually the same. So I'm going to change that. So then our displacement would be the integral from 1 to 5 of t squared minus 8t plus 12 dt, which of course would be, which turns out to be negative 6.666. And our distance would equal the integral from 1 to 5 of the absolute value of t squared minus 8t plus 12 dt, which would be 11.333.